How does a small handheld tool use electricity to melt metal? Inside it, electrical energy is turned into heat by a special heating element. This is how a soldering iron works. A soldering iron is a tool designed to produce heat. Its job is not to melt the wires themselves, but to melt a metal alloy called solder. When the solder melts, it flows around two metal surfaces. As it cools, it hardens and joins those surfaces together, creating an electrical and mechanical connection. Although a soldering iron looks simple from the outside, several parts work together inside it. The main parts are the handle, the heating element, the metal tip, the protective insulation, and the power cord. Each part has a specific job, but the heating element is where the heat is produced. Let's begin the moment you plug the soldering iron into a power source. Electricity travels through the power cord and enters the heating element. The heating element is usually made from a material with high electrical resistance, such as nichrome wire. Resistance means the material does not allow electricity to flow as easily as copper does. Think about rubbing your hands together quickly. The harder and faster you rub them, the warmer they become, because friction produces heat. Something similar happens inside the heating element. As electricity flows through the high-resistance wire, the moving electrons interact with the atoms inside the material. These interactions make the atoms vibrate faster. That vibration produces heat. Unlike copper wire, which carries electricity with little heating, the heating element is designed to produce heat efficiently. This is what makes the soldering iron useful. The heating element is wrapped around or placed close to a solid metal rod that leads to the soldering tip. As the heating element becomes hotter, the heat moves into the metal tip through heat conduction. Heat conduction means heat moves from a hotter object to a cooler one when they are touching. You can imagine placing one end of a metal spoon inside a cup of hot tea. After a while, the other end of the spoon also becomes warm because heat travels through the metal. The soldering iron works in a similar way. The heating element becomes hot first. Then the metal tip absorbs that heat until it also becomes hot. The tip is usually made from copper because copper transfers heat quickly. It is often coated with other metals to protect it from wearing out while still allowing it to transfer heat efficiently. As electricity continues flowing through the heating element, the tip reaches a temperature of about 300 to 400 degrees Celsius, depending on the type of soldering iron and its intended use. At this temperature, the tip is hot enough to melt solder when it touches it. At this point, the soldering iron has completed its main job. It has transformed electrical energy into heat and delivered that heat to the metal tip. Everything else that happens depends on this hot tip. Now that the tip of the soldering iron has become hot, it is ready to do its job. But here's something important to understand. The soldering iron is not designed to melt the solder by touching the solder alone. Instead, the hot tip first transfers its heat to the metal parts that need to be joined. This allows both pieces of metal to become hot enough to melt the solder. This creates a strong and reliable connection. Imagine placing an ice cube on a warm plate. The plate transfers its heat to the ice until the ice begins to melt. The soldering iron works in a similar way. The hot tip touches the metal wire or metal pad, and heat flows from the hotter tip into the cooler metal. This process is called heat transfer. As the metal becomes hot, you place the solder against the heated metal, not directly against the soldering iron. The solder reaches its melting temperature and changes from a solid into a liquid. Because molten solder flows easily, it spreads across the surfaces of the metal. This is called wetting. Instead of sitting on top like a drop of water, the melted solder flows around the metal and fills small gaps between the two surfaces. When enough solder has flowed into the joint, you remove the solder wire first, and then lift the soldering iron away. The metal begins to cool. As its temperature falls, the liquid solder also cools and changes back into a solid. This solid solder holds the two metal pieces together, creating both a mechanical connection and an electrical connection. A good solder joint should look smooth, shiny, and evenly shaped. This usually means the solder melted properly and bonded well with the metal. If the solder looks dull, rough, or cracked, it often means the joint moved before it cooled completely, or the metal was not heated enough. These are called cold solder joints, and they may not conduct electricity properly. Another important part of a soldering iron is temperature control. Some soldering irons heat to one fixed temperature, while others allow you to adjust the temperature using a control dial or digital display. Different jobs require different temperatures. Small electronic components usually need lower temperatures, while larger metal connections require more heat because they absorb heat more quickly. While the heating element becomes hot, the handle remains safe to hold. This is because the handle is made from materials that do not conduct heat easily. These insulating materials slow down the movement of heat, protecting your hand while you work. This is also why the power cord is covered with insulating material to protect you you from electrical shock. To keep a soldering iron working properly, the metal tip should be kept clean. Over time, dirt and oxidation can build up on the tip, making it transfer heat less effectively. Wiping the hot tip on a damp sponge or brass wool removes these deposits and helps the tip transfer heat efficiently. When you look at the entire process, a soldering iron follows a simple sequence. Electricity enters through the power cord and flows into the heating element. Because the heating element has high electrical resistance, it converts electrical energy into heat. That heat travels into the metal tip through heat conduction. The hot tip transfers its heat to the metal parts being joined. The heated metal melts the solder, allowing it to flow around the joint. As the solder cools, it hardens and forms a strong electrical and mechanical connection. A soldering iron is an example of how electricity can be transformed into heat and used to make connections in electronics and electrical work.